Time we get to start diving into tabs, blink, and cosmic clarity. Welcome to Seti Astro. Well, it's time we hop into these tabs. So, Image Viewer is the first tab, it's the landing screen. It used to be called XISF Liberator. It does more than just that now, so change to Image Viewer. You're going to see the main preview in the middle. On the right will be for any metadata that may be in your file, specifically for FITs or XISF files. And beyond that, there's only a batch conversion process. So let's just open up a file and check it out. All right, I opened a linear XISF file, and you can see XISF files have a lot of weird structure in their tree, but it does have fits keywords and a bunch of other things, including all the warps for the astrometric solution that PI generates, a lot of weird hash things. Anyways, on the right-hand side, if you want to save this metadata, you can save it out as a CSV file. There's a button to fit to window and an auto stretch. The other thing that is in here that is often overlooked is the XISF converter batch process, where you can select an input directory, an output directory, and the format. So you can convert all your XISF files to fits, TIFF, especially if maybe you're on a free trial of PixInsight and you're not going to continue with them. You don't need to scrub those files. You can batch convert them all right from in Image Viewer here. And while you're in Image Viewer, you could hide the header off to the side here. You don't need it visible the whole time either. Moving along to the blink comparator. This is one that's had a lot of changes recently. So let's dive into it. This is a means of looking through a whole bunch of your images, blinking through them, so you can remove any bad ones prior to stacking. So there's select images, a select directory. If you have all your FITS files just in one directory, you could just do that. There are some forward and back buttons, a play button where it'll just cycle through all your images. After you flag things, we'll talk about flagging. There's a button for that. There's a clear images in the tree box, so you could load new images. Zoom out and in, fit to preview. And then this also has an aggressive stretch mode. When they're all first loaded in, they're all normalized and stretched. But sometimes you may want a more aggressive stretch to see what's going on, maybe in the background, gradients, dim satellite trails, things of that nature. So let's go ahead and select some images here. Now when you're loading images, it will utilize pretty much all the cores in your CPU to try to load everything as fast as possible. Once all the files are loaded, you're going to see that it actually separates out everything from the object type, the filter, and exposure lengths, depending on what's in the header data. So you can actually have it well organized within your blink viewer here. You can use the up and down arrows to blink through the images. And like I said, you could also hit the play button and have it auto scroll through for you. Hitting the pause button, because of how it's coded, there's only a brief window when it's looking for the pause button. So just click it a couple times until it actually pauses. Other things to do in here, you can highlight and select multiple ones at a time, and you can right click them and do a bunch of stuff. You can move the selected items to a completely different directory. So if you have some that you just want to move, whether they're weird looking and you want to analyze them further later, you could actually delete them. These will delete them off your hard drive. If you have a single one you're looking at, you can click push image for processing, and that's going to push it to the slot so you could actually view it in other tabs here and manipulate them if you needed to do some additional manipulation to see what's going on. You could also rename the file. This will rename the file for you. And then the other feature is to flag. If you just press the F button on the keyboard, it's going to flag it and move to the next item on the list. So you can just continuously keep pressing the F button if you have a batch of like when clouds came by, and it will flag it and move it to the next item. If you press F again on a flagged item, it'll unflag it. You could also just click clear flags if you just want to remove all the flags. And when you do have a bunch of items flagged, if you right click anywhere, you can do the option to delete all the flagged items or move all the flagged items as well. So now let's go into show metrics. When you first click show metrics, you'll get a warning saying that it's going to use all your cores, and the UI is probably going to freeze on you. There is a checkbox on that so you don't see it again. And I'm just going to click show metrics. I won't get the warning. I've already said that's fine. And you'll get a screen saying computing frame metrics. All right, when it's complete, you'll get your metrics window here. And what's really great about it, there's a drop down here so you could select what filter you're actually looking at versus all of them, right? So we had L, G, and R actually loaded in our Blink for the moment. And we can go ahead and talk about what all these graphs are meaning and how to go about utilizing them. So full width half max is how big the stars are, right? So maybe your focus was drifting. I don't know, the mount got hit by a bird or something and it vibrated all around and made big fuzzy blurry stars. Eccentricity is the amount of out of round the star is. 0 would be a perfect circle, and as you get more and more oblong, that number goes up and up and up. The background is just how bright the background is. This will be really good to tell if like a passing cloud came by or something of that nature. Just because of how it scales, look at the left-hand side. The variance may not be as big as you think it is if the y-axis has some really tight values. And then star count is just how many stars it was able to count in the frame. Again, a great telltale sign if like clouds or something pass by, your star count's going to drop pretty dramatically. The other option you can do is if you shift click on a dot, it's going to pull up that image for you. So you can see what's actually going on in the image as to why it was a potentially flagged item. So you can see what the star shapes look like. You can look around and see what's going on with the particular image. And you can compare that to, a different one to see potentially like what's going on. Why did it flag, right? Or why does it have bigger out of roundness than others? See, this does have like a trail. It definitely was bumped, but it doesn't necessarily mean that it's a bad frame you want to reject. But there's an easy way to reject based on a whole class of issues. If you click and drag the red line down, you can just flag a whole bunch of them. And if you look over in the Blink tool now, you can see that they're all flagged based on these ones that were flagged here. And same with things like star count. You can just grab and drag up that if you just want to flag out some of the ones that were potentially had clouds or something drift by, and it had much lower star count than the others. That's just another way to go about it. And now that you have all these items flagged, we can go ahead and close that, and you can just right click and either delete all the flagged items or move all the flagged items, right? It's just it's a Great way to do culling of your images. You can visually see what's going on with the metrics, and you can use those metrics to help you determine what is or isn't a good frame that you may or may not want to reject. All right, moving over to the Cosmic Clarity tab. On the left-hand side, you're going to have your options to load an image, but you probably already have your image loaded. There's an auto stretch on and off. Sharpen, denoise are both, and as you change those, your options will change. If you do have it on both, it's going to do sharpening first, followed by denoising, or the super resolution upscaling option with 2x, 3x, or 4x. It'll also show you the folder where Cosmic Clarity directory is pointed to and the wrench icon to set that directory. For Sharpen, denoise, and both, you're going to get the option for use GPU acceleration. You're just mostly going to have that on yes, unless you have an issue with your GPU that doesn't support the hardware acceleration. For Windows users, hardware acceleration can be used on NVIDIA, AMD, and ARC cards. For Mac, it's going to be the Metal Performance shaders on the Apple Silicon editions of Macs. And then for Linux, unfortunately, only NVIDIA has the acceleration. For sharpening, the sharpen modes are both stellar only and non-stellar only. There's a option to sharpen RGB channels separately. This normally just should stay on no. The only time you would ever put that to yes is if you have really bad like blue or purple fringing on stars and you need to sharpen those color channels separately to deal with those stars differently. For non-stellar sharpening, PSF, this is going to be how big the stars are in your image to tell the non-stellar neural net how much deconvolution or how much sharpening is going to be needed. One way to get this number is if you click the PSF viewer either up here or under star stuff. Now it may take PSF viewer a minute or so if you have a lot of stars. In this particular image there's 14,000 stars that are cataloged, but now you can see that the median half flux radius is right at about 2.2. So that's what I would use in here. It's a guideline, right? So roughly 2.2, 2.5. I'm okay with that. Stellar sharpening, that's just how sharp you want it to take the stars. If you have it all the way at 1, that's just going to be the full blast of what it thinks the sharpened star should look like. But I find normally like a 0.6 to a 0.7 is fine. And then same with the non-stellar sharpening, how much sharpening you want the neural net to attempt to apply to the image. I'm going to go with like a 0.7 as well. We'll just keep those at 0.7. And then if you don't have a dedicated GPU, this process does take a long time. You may want to click select preview area. And what that's going to do is it's only going to run sharpen or denoise on this little preview area such that you can see if those are the settings you actually want. So it gives you a chance to just run it on the small section, tweak the settings, run it again, and then when you get the settings how you like it, you could apply it to the whole image. So I'm just going to say process the visible area. That's just going to be this little area here. And then you can see if that's the level of detail you want. You can click undo and then try your settings again. For me, I think the 2.5 was a little aggressive with the amount on it. I'm going to go 3.5. The stars are already pretty sharp. I'm going to pull that down to like a 0.6. And then for denoise, you have the denoise strength here. Again, full blast is a 1. It's just what it thinks the denoised image looks like. You have a couple options, full or luminance. For a mono image, luminance and full, it's the same thing. But for a colored image, luminance, it's only going to denoise the luminance. And then full, it's going to do a full denoise of the separate R, G, and B channels. So it does take a bit longer. But if you have a lot of color noise in your image, you may want to do the full denoise that route. And then again, with both, it's just going to do sharpen, then denoise. And I'm just going to execute it now on the full image. You may see this enabling autocast. That's just if you have a new enough GPU that it can run autocast, and it will turn it on to help speed up the process a little bit. And now the sharpening's done, and in the lower left you can see it says underscore sharpened. And now it's going to run through the denoising. And now when you turn your auto stretch back on, you can, well, it's an auto stretch, so you can see what's going on in your full image. And then again, super resolution is just the options 2x, 3x, 4x. That's really going to be used if you've already stacked your image, you've already maybe even drizzled it, but you're still fairly not well sampled for your image. You could always do like a 2x upscale. And that's going to be a neural net assisted interpolation. So it does a standard interpolation and then runs it through the neural net for that. Moving on to Cosmic Clarity Satellite. I think this is one that doesn't get used as often as it should. Where it really should be used is when you're acquiring the data, you could set it up to live monitor an input folder. And then as your images come in, it's going to look for a satellite trail and clip the satellite trail to black, which is the preferred method. So let's work through the whole image or through the whole UI here. There's a select input folder, select output folder. Again, GPU acceleration on or off. The satellite removal mode is going to be full or luminance. Same thing with the denoise. It could either strip it out of the luminance completely, which is fine for most things as well, or full, where it's just going to look at the RGB channel separately. This may be good if you have a flashing satellite that's glinting, and it may be glinting in such a way that you get like a green, then a red, then a blue kind of streak, depending on how it's interacting with the sensor. Again, clip the satellite trail to black. Instead of replacing the satellite trail like you would with star removal, where it removes the star and then replaces the star with what it thinks was behind it. That's what the satellite trail removal is doing. You can clip it to black instead. So when you stack it, the stacking program just completely ignores those clipped pixels anyways. It's like they never even existed in the stack. Like that frame didn't even exist in the stack for those particular pixels. So that's why it's set as the default. And then there's a clipping sensitivity. You're going to have to play with this. If you have more aggressive clipping, you may notice it starts clipping other things along the satellite trail that you didn't want, like diffraction spikes or pieces of galaxy cores, things like that, where it was on the cusp of being resolved by the neural net looking for satellite trails or not. And then there's also an option to skip save if no satellite trail is detected. So it's only saving the images that are changed. In general, you want to keep that off so you know all the different frames it's actually ran through. There's also a button to process just a single image. You could batch process an input folder. Again, there's the live monitor input and the wrench icon to tell it what folder Cosmic Clarity is sitting in. So let's go ahead and do some of this here. So I loaded a folder where I just have a test file in. I have an output folder, and it will give you a list of the file names in those particular folders. Now there's some things you can do right from right-clicking on the file names that'll be in here. You can delete the file or rename the file. That will delete it off your drive completely. You could also double-click it, and it's going to pull up the actual preview of the image for you. And it has an auto stretch. And you can see this one has a number of trails going right through it. It looks like geostationary satellites in this particular image. In this case, we're just going to want to batch process the input folder. I'll just leave everything on defaults right now. You're going to click batch process the input folder and just give it a moment, and another UI is going to pop up. This is going to be the little window that's going to show you it actually processing the images as it's going through them. And now we can see that our new file showed up here. It says satellite it when it's been processed. Again, we can double click this. And the satellite trail has been clipped to 0. There's some other pixels that look like they were clipped to 0 as well, along where it's detected the satellite trail. That's really not as much of a concern because, again, in the stack, those pixels are just going to be ignored completely anyways. The vastly more important thing is the satellite trail itself being clipped. But you can play with these settings here, more or less aggressive. Like we could set it something like this and just process again. And now lowering the sensitivity like that. Now those other little pixels aren't rejected either, and it's only the satellite trail that's clipped to black. So that's how you would use this sensitivity slider. And then, like I said, the other really good one is this live monitor and input folder, where now if this is selected, you press it. Now your UI is going to come up and say the live monitoring has started. And any new file that shows up in our input folder is going to be ran through the satellite trail removal process. So you could set this up so your input folder is the folder where you're saving your files as they're coming in from your telescope throughout the night. And it could be processing your images to remove any satellite trails it detects throughout the night for you. And then you'll have a whole folder in your output directory folder of all your satellited files ready to go, ready to be thrown into your stack. And you don't even have to worry about satellite trails anymore. In closing, that stops the live monitoring. I think this will be a good place to stop this video. We've gone through Cosmic Clarity, all the different options within Cosmic Clarity, and talked about all the different changes here in Blink Comparator. So these two are probably going to be used quite often. And then just some of the additional features here in Image Viewer, which you may not have known about either. Please comment, like, and subscribe.